Seaborn is a statistical plotting library in Python. It's built on top of matplotlib, which means when you run a Seaborn command, it runs a set of matplotlib commands under the hood. It's built with beautiful default styles for the graph, which makes it easier to read and comprehend. Seaborn is designed to work very well with pandas data frame objects, and therefore it's the go-to library for plotting data in Python. To install the Seaborn package, you would need to use the commands conda install Seaborn if you are using the Anaconda prompt, or otherwise pip install Seaborn if you are using the command prompt. So Seaborn can be used for analyzing different types of data by using different types of plots for numerical data, for categorical data, and even for data in matrix format. So let's start by importing our libraries and some data to work with. So here we will import numpy snp, import pandas spd, import matplotlib.pyplot splt, import seaborn as sns, and we will run a one-line code matplotlib space inline. So this last line %matplotlib space inline, this will help to see the visualizations in the Jupyter notebook. Next, we will upload the dataset. So Seaborn comes preloaded with some datasets which we can use for practice purposes. So one of such datasets is called tips. To load the datasets, we can run the command sns.load dataset and just pass in the tips. So we can check the doc string here. It says load an example dataset from online repository. So this function provides quick access to a small number of example datasets. So we can use it for our practice as well. Let's run this. It will load the dataset. So let's check the head of the dataset. So this is our dataset. So it looks like it's from a restaurant. We have the total bill and we have tip data, and then we have some other categorical data. Now let's check the info. So in total it has 244 entries, range index going from 0 to 243, and 7 columns. Total bill, tip, sex, smoker, day, time and size. There are no null values here, and as we can see, the first two columns, total bill and tip, are float data. Then the next four are categorical data, and the last column seems to be integer data. So now that we have our data, let's move on to the grids. Grids are used if you want to further customize the graph we have seen earlier. Grids are general types of plots that allow us to map similar or different plot types to row and columns of a grid. This basically instantiates the figure object and plots the axis on that, and then we can plot whichever way we want to on them. So basically it creates a plot like subplots, and then we can plot the customized graph on those subplots. So here we have two kinds of grids, PairGrid and FacetGrid. PairGrids are used for pair plots. These are the base of pair plots, and then in place of Seaborn automatically placing the plots on those, we can select the type of graph we want on those grids. And similarly, we have a facet grid which will create rows and columns for the categorical data in our data frame, and then we can plot the graph we want on those based on the rows and columns. So first, for the grids, we will use a new data set called iris. Iris is one of the most famous data set in the data science circle. To load this, we can use sns.load_dataset and pass in iris. And let's check the head of this. So here we have a column called sepal length, sepal width, then we have petal length, petal width, and then species. So these are basically kinds of flower, and we have the length and width of the sepal and petal with us. So let's check the info to get more information about this data set. So here, as we can see, there are a total of 150 entries ranging from row index ranging from 0 to 149, and then there are 5 columns. As we have already seen, there are no null values. The first 4 columns are all float data, and then the species is an object. So this is basically a string object here. If you want to further check this species column, we can do a value count here, dot value count. So as we can see, there are 3 different values in the species. Those are Setosa, versicolor and virginica. These are the scientific names of the flowers, and there are 50 entries for each of those. So in total we have 150 entries in the data set. Now for a data set like this, earlier we saw how to plot a pair plot. Let's quickly check that as well. For this data set, you can just pass in the dataset name and it will automatically plot. Yeah, so it's a variable, so we need to pass in without the inverted comma. And let me zoom in. Is it called zoom in or zoom out? Let me zoom out a bit so we can see the entire pair plot. Yeah, so here we have our sepal length, sepal width, petal length and petal width on both rows and columns. That is on both y-axis and x-axis, and the diagonal elements are histogram for univariate data, and then we have scatter plots for each pair of numerical data in that data set. So when you compare this sepal length to sepal width, we can see there are 2 different clusters here. Similarly, when you compare sepal length to petal length, once again there are 2 different clusters, and we see the same pattern with all of the x versus y comparisons here. Now let's say you want to customize this graph further. Rather than using pair plot, what we can do here is we can use pair grid. So a pair grid is a subplot grid for plotting pairwise relationships in a dataset. A pair plot is the simpler version of pair grid. So what we saw here, we will get our subplots with the same variables on the y and x axis, but we can customize the individual plots here. So the command for this is sns.pairGrid. Uh, Notice the capital P and capital G here for the pair grid, and then we can pass in our dataset name, run this. Let me zoom out again so you can see the entirety of this pair grid. So as you can see, on the x-axis we have all of the same variables as on the y-axis, which we had earlier for the pair plot. Now what we can do here is set this as a variable. Let's say this is equal to g. So if you call g, we will get the same pair grid, sorry, and then we can map on this. If you use map method and press tab, you will see we'll get these options for map underscore diagonal, which will map on this diagonal subplots. Then we have map underscore lower. They select these subplots which is below this diagonal line, and then we have map underscore occur, which selects all of these subplots which is above the diagonal line. So we will use all three of these. We will customize one kind of plot for the diagonal, which would be univariate data. Then we will use another kind of plots for the upper, for x versus y comparison, and because we already have the same comparison, we will use a different kind of graph for the lower. Let's go with map underscore diagonal. Here we can pass in the name of the plot which we want. So if you look at the doc string for this map underscore diagonal, we have to pass in the function, and then we can pass in other keywords as well which goes with that function. So this plots a univariate function on each diagonal subplot. So let's check what this gives. So what we have here is we have our histogram for univariate data. If you want KD plot on top of this as well, you can use the keyword KD is equal to true. So we have that. Now let's say we want to plot on the upper diagonal. So we can use g.map, select map underscore upper, and then let's say we want scatter plot on this. So we can use plt.scatter for that. Run this, and so it will plot the scatter plot for all of these x versus y variables. Now since we already have the sepal length versus sepal width, we don't want a plot for sepal width versus sepal length. We will just be inverse of this graph here. So rather than that, if you want to see a different kind of graph to see the relationship between sepal width and sepal length, what we can use here is map underscore lower, and then pass in, let's say we want a KD plot for this. So see, KD plot is different from this scatter plot. And now if you compare this to the pair plot which we plotted earlier, let me go back up. We have the exact same graph on the diagonal and on the upper subgrids, but if you look at the lower subgrids, we had scatter plot there, which will just the inverse of what we have here. The data was just inverse of what we have on the upper subgrids. So here we have a different kind of subplots, and we can analyze the data using two different plots here. So this is the benefit of being able to customize the graph on the pair plot using a pair grid. So now that we have our pair grid, let's move on to the facet grid. A facet grid is the general way to create grids of plots based off a feature or a categorical data. Feature is nothing but the categorical columns in a data frame. So it can have up to 3 categorical data divided as row, column and hue. So let's see this. Once again, see the F is capital and G is capital. Normally when we were plotting the other graph, all the letters were small. But when you are using the grid, either pair grid or facet grid or even joint grid, we won't cover the joint grid here, but it is just the grid for the joint plot which we had. So for facet grid, let's check the doc string. So here we need to pass in the data. Then we have an option for row. You can pass one of the categorical columns for that, and that will divide the plot for each categorical data. Then we have a parameter for column where you can pass in another categorical column, and then we have an option for hue as well. So remember, hue will separate the categories based on color combination. And then we have some parameters like height and aspect. This is nothing. Height is the height of the subplot, and aspect ratio is the ratio of height and width. So if it's 1, that means if you pass in height as 4, the width of the subgrid would be 4 as well. So let's pass in our data first. we will use our tips data frame for this. And then let's say for the row we want to use the smoker column. Let's check the tips data set first. Let's check the head of the tips data set. So remember, we have two floating column for total bill and tip, and then we have four columns for categorical data, sex, smoker, day and time, and then we had a size column which is integers. It was just the number of people here. So let's say we want to divide on the row the smoker, the values for the smoker column are yes and no. So we want a separate row for yes and a separate row for no, and then we further want to divide the data by this time column. The time has categories lunch and dinner. So let's run this, and so this is what it gives. So on the rows, if you see, the top row is yes, smoker yes, and the bottom row is for smoker is equal to no. Similarly, on the column we have used time. So on the first column we have lunch, and the second column we have dinner here. Now, just like the pair grid, we can save this as a variable, and then we can map on that variable. So here, let's say we want to see histogram for total bill. So if you check the doc string, once again you can pass in your function and then keywords related to that function. If you look at the doc string for hist plot, the very first parameter is x. So we already have the data here. This facet grid is based on this data, so we don't need to pass in our data. We can directly pass in our column name for total bill. Let's run this, and we have our histogram for the data divided by smoker and with time on the column. If you want KD plot on top of this, we can pass in true for that, and it will plot the KD curve on top of the histograms as well. So see, this is very useful to analyze the data. Here we have already used one column from the data frame, divided that as rows, then we use another categorical column and divided that as column, and then we have the ability to further divide it as U as well. Let's plot another facet grid and we will check. So let's say for the same data set, so for row we have smoker, for column we have time, and let's say for U we will pass in sex. And now we will plot scatter plot for this plt.scatter. For scatter we need two variables, x versus y. So you can pass in total underscore bill. This will be for x axis, and then for y axis we can pass in tip. So let's check this without, so hue has got nothing to do with it. X and y must be the same size. So you cannot pass in y is equal to, because that parameter doesn't exist under map. You directly have to pass in the functions here. For scatter plot you obviously need x and y, and you can directly pass in your columns here. So here, as you see, the graph is already divided for smoker on the rows, and then it is further divided by time data for columns, and then we divided it based on sex, based on colors. So we have so right now we don't know which color this blue and orange represent, so we can add in the legend for this. So here we know blue is male and orange is female. This is same for the entire data set. You can also give a location for this. and we'll move it outside. There's another way of doing it. You can directly add it here. You can use underscore add underscore legend. Run this and it will come outside. So here we have blue color for male, orange for females, and you can distinguish between male and female data on the scatter plots itself. So next we will move on to the regression plots.